Hello and welcome to another video. Today I'm talking about this black box, which is a US Army Signal Corps frequency meter type BC-221-M. It's a heterodyne type frequency meter, i.e. you zero beat it, and it will cover from 125 kilocycles up to 20,000 kilocycles, or 125 kc up to 20 megs. It can do this in two ranges, from 125 kcs to 2 megs and 2 megs to 20 megs. In the bottom section are some spur valves. There's 3 valves in here, the same type that's actually used inside it. It's got a 1 meg crystal oscillator built in, a calibration book, and controls such as on and off. To power it up, you also need to have a phone jack plugged in, because that makes the contact for the heaters. We have a function switch, which is the internal heterodyne oscillator, a crystal check, which is what you use to calibrate it, or crystal only, so you can actually check the trimming of the 1 meg oscillator that's built in. Typically, for calibration, crystal check; for use, heterodyne oscillator. We've got an audio gain control, so you can hear the heterodyne on earphones, and I'll be plugging in a simple valve amplifier so you can hear it over the camera. The low band switch, in low it covers 125 kilocycles up to 2 megs, and in the high it covers 2 megs to 20 megs. This is a frequency corrector using the calibration scale, and this is a 0 to 50 on the main, 0 to 99 on this, and a vernier giving a fraction of a rotation on the dial. The calibration book at the bottom gives you frequencies and expected dial locations for them frequencies, and once it's calibrated it's quite accurate. What I'm going to be doing is trying to run it up on, say, 2 frequencies, 3 625 kilocycles, and say 7 125 kilocycles, to simulate something for the 80 meter and the 40 meter band. The reason these were very popular for the radio amateurs is because it was a stipulation of the licensing conditions that you had to be able to check your frequency of operation. So after the Second World War, when these started to come onto the market, they were taken up by the radio amateurs to fulfill one part of the operating guidance. So I'm going to be using a frequency counter. I'll plug it into the wire terminal on top. There is a coax socket terminal here, although I don't have the matching coaxial plugs, and I can check both the 1 megs oscillator and check the calibration, and then check it, setting it for a particular frequency that we want to use. Say, as I said, 3 625 and 7 125 kilocycles. So let it warm up a little bit, and then I'll come back with it all connected up. Okay, I'm going to look at the frequencies in use that I'm going to use. I want to calibrate it for I want to use it on 3 625 kilocycles. At the bottom here it's got some crystal checkpoints, one of them being 3666.7 kilocycles, so that would be 3666.66666 in theory. So I'm going to set it for this first to calibrate it. So I'll put the function switch onto crystal check, and I'll set 3843.9 on the scale. So I'll move back up so you can see what I'm doing. Let's go Get my audio connection so you can hear that. 38 43 and 0.9 would bring it to that position there. Have I got that lined up? Near enough. Let's try and get it spot on. So there, that's the dial set to where the crystal checkpoint says it should be. And now I'm going to use the corrector so I hear a 0 beat tone. Which should be there. I can hear it rumbling. Close enough. I'll take it out to the crystal oscillator checkpoint and I'll just move across to the counter, and there I'm showing 3666.66 kilocycles. Right, so if I now want to set it to be 3625 kilocycles, it says I need to dial in 3758.5. So take it back one, that's 37 there, 5, 8, and then I want 0.5, which would be there. Am I lined up? I can't really tell without sticking my head round. .37, 5, 8. .5, best I can see it there. Now that will now be generating a tone or a carrier on 3625 or close to it. If I check the counter, I have 3.624966 megs. So, shall we say within a few cycles of the correct frequency. And just out of interest, if I use my FT902, as I tune in, turn it up so you can hear it a bit better. So that 0 beats at 3625 megs, which is what you'd do then to a receiver to 0 beat it to make sure it's on net. Okay, next one I'll try will be 7 megs, and what I'm aiming for is 7125, around there. So let's just do a quick setup. Go back a page for 7125. 7125 is 7124, 7126. I might have to interpolate. So I'll do 7124 megs. The nearest checkpoint is at 7 megs, so I have to set the dial to 35031 to generate 7 megs. So 3503.1 is close to that. Turn my radio down. Net that. There we go, netted. Take it off to that mode, and then for 7124 I need 3629.9, 3629.9, 3629, and to get the 0.9 would be there. And what that is half the frequency, because it uses a multiple of that to give me the 7. So if you double that up, you would get close to 7124. And I shall go back to the FT902. This is just doing a check on the FT902. It's 7.124. Turn it up. A weak carrier coming in from the counter, from the meter. There you go. 0 beat happening there. On 7124 megs. The accuracy of these things was meant to be something like I think 2 kcs at 20 megs, something else like that, but better accuracy of a few hundred cycles can be given with care. Oops, not the camera. As I say, there's spare valves in there. If I spin it around, let's move the frequency counter out of the way. On the back of this unit is a homemade power supply. There we go, homemade power supply. This gives 6.3 volts and 135 volts DC for the heaters, and here is a circuit diagram. I shall zoom in on this. And hopefully you'll be able to see it. Circuit diagram with the oscillator section. This here is the crystal oscillator and mixer, and here is the audio output stage to the over there to the headphones. Power supply comes in at the bottom. So all in all, this box, which is getting quite a bit older now, I've no idea when it was actually produced, apart from seeing the September 1944 on the box to say when it was last moisture and fungus proofed. I don't know when it was made prior to that one, but for something which is going on for, shall we say, 80 years old, it's still a working box and still doing quite well. This one I had to repair the selector switch. This has a 2-position wafer, 4-pole wafer in the back of this. The centre of it was actually broken. When I got it, I have used some heterodyne to put the halves together. Seems to be working quite well. I couldn't get this switch apart without doing major damage to the actual box, so I thought that was the best way to go for the time being. So, a working unit. Hopefully soon I shall have a British Wavemeter Type D to have a play with and do a comparison against. Thanks for watching.